It's been extremely hot outside, so I haven't really been working on anything. I think it's like 115 with the heat index. I thought I'd make some kind of little video to show you guys something. Trying to get the ignition timing map out of this EZL. As it turns out, this is not the correct one for my car, so that's why I decided not to go through with this process. But basically, I have a signal generator here that is simulating the crankshaft position sensor. So that feeds in here. And then this is the connector for power ground and the low side of the ignition coil, which I just have a resistor here. I'm using a battery because I don't have a very good power supply, and I wanted a clean DC signal or clean DC power supply. So this little resistor just acts like the load for the ignition coil, so I'm reading the ground wire of the ignition coil into the oscilloscope. This connector is what connects the coolant temperature sensor and the reference resistor inside the car. And then of course this is the vacuum port. So I can already see what the issue with recording this analog scope is going to be. I don't want to turn the intensity up too much and burn out my scope. Basically what we're seeing here is the AC signal being the crank sensor, and I believe there's 4 pulses per revolution on the Mercedes-Benz. But what the module does is it uses a zero crossing detection to establish the edge of that tooth. So internally to the EZL, it's probably has a comparator built into it. And using that comparator, it creates a square wave that triggers the processor. And then the processor does some math to figure out the frequency and therefore the time associated with such. There you can see it a little better there if I adjust it. Anyhow, so it detects the zero crossing point on either the rising or falling edge. And then it says, well, if I'm at 1,000 RPM and I need to start charging the coil, say here, and then when this signal goes high, because I'm looking at the negative side of the coil, when the signal goes high, that's actually the EZL basically removing the ground from the ignition coil, which will cause the high energy spark to discharge to the distributor. So every time we see the signal go high, we're actually seeing what would be an ignition event on the square wave pulse. So I have a little vacuum line connected to the EZL now. If I pull a vacuum on it, you can see the EZL advances the ignition, and that's to be expected. At lower manifold pressures, there's less cylinder pressure, and therefore you need a more advanced ignition timing because of the slower burn. So my idea was basically to set this up with some known conditions from the service manual. I believe it has a spot for 3,000 RPMs with vacuum and without vacuum, and then I think an idle speed of 750 with and without vacuum. I was going to set those known speeds just by using the frequency of the crank sensor signal here. And then once I have the frequency set, I can look at the time, and I'll just because I don't have a digital scope, this would take quite a bit of work, but I'd have to keep working in between the time and the frequency domain. Or I'm sorry, the time and what would be the crank angle domain. And I would just say, well, I know according to the literature I'm supposed to have, I forget what the numbers were, but maybe 20 degrees of advance at 3,000 RPM. So I'd say, well, this is however many milliseconds here. And then I would be able to work out, okay, I'll set that to 20 degrees. Since I don't know the actual zero crossing point of this signal, because I don't know where the teeth on the flywheel are timed to the engine. But using those known values from the literature, I think I could say, well, I'm calling that 20. Go ahead and define that as 20. And then just slowly change the variables in the EZL. So something I could do is put a vacuum on it that would be representative of the engine idling. And be able to say, okay, well, there's it at idle. And then just slowly keep working through different speeds. I can advance the speed. You can see the dwell time basically becomes reduced. Or, I'm sorry, what would be the spark duration, but it only takes a millisecond here. I'm set at 2 milliseconds per division, so there's still about 2 milliseconds there. So the spark would already be over, but you can see the dwell increases with speed, or I mean, it looks like it actually stays pretty much the same, but the high enough RPM, you're going to run out of usable spark time. Here you can see this is 200 hertz. You can see it wouldn't have enough time to fully fire that coil. But here you can actually see a little bit here on the right where changing the speed increases the advance. See how that curve just kind of jumps right there? Going very smoothly on the frequency knob, but you can see the square wave kind of jump towards the crank sensor. So that would be the advance with ignition, or with engine speed. And you can see it approach more there. So I think it's pretty cool to see. I know my scope is hard to record, but you can see how it advances the ignition with RPM and how it advances it with vacuum. So that was basically my plan, to figure out what the factory ignition timing was of these modules. I'd have to stick a resistor in for the coolant sensor and to stick the 750 ohm reference resistor in, because if I touch those pins, you can see, I believe this is the reference resistor. I'll have to pull the schematic back up really to know, but you can see that pin, if I connect it through a resistor to ground, it advances the timing quite drastically. And this one, I think this is the coolant one actually. This is just kind of, looks like it retards the timing just a little bit. You can kind of see it jumping there a little bit. So that was my plan. I'm not going to do it because it would take me an exorbitant amount of time to do so with this analog scope. And also, this is the wrong ignition module for my car, so it wouldn't give me the correct information I needed anyhow. I just thought maybe you guys would like to see that. I thought it was kind of cool to get the EZL working on the bench and look at how you could maybe go about pulling the ignition timing curve out of it. Thanks for watching. Bye.